thank you. It's a pleasure to be here and to talk a little bit about water and climate variability. And following Deke and Gary McManus, I think, is appropriate because they're the scientists that put the data together. What my area of interest is in water resources, and the profession takes that information and then plans the infrastructure to supply water and to supply water during a drought or any other part of the year. So next slide. The charge was, if a severe drought situation across the Midwest continued, and also in Oklahoma, what types of solutions should be considered to address the water as a sustainable resource. And so, continued drought, what course of action? Well, if we look just back in December, we had a map, the U.S. Seasonal Drought Outlook showed a large area of persistent drought, shown here in brown, across the Midwest and West. Next. And just downloaded this yesterday, and starting March through May, you can see it's lessened somewhat. And so now we still have a large area of persistence, but in this area in the upper Midwest and western Great Lakes, it's diminished somewhat. Well, things change, and so next slide. And so we can look at stream flow and in relation to the drought. So 1 year ago, the drought was very severe in West Texas, so next. Then this year, it's expanded throughout the Midwest. But if we look at stream flow, next slide, in Oklahoma, if you would have checked the same map from the United States Geological Survey just last year, you would have seen below normal almost throughout the state. But you can see the green and the yellow dots just say there's actually some above normal, actually quite a few above normal. That's for this time of year. Now, what remains to be seen will be what happens when the summer temperatures increase and runoff decreases. And this is typically our wet period. So the question from a climate standpoint is, well, what will each weather system bring? Will it bring a net increase or a decrease in the stream flow? The stream flow integrates all of the various factors, the precipitation, the evaporation, the soil conditions, vegetation, and so forth. Next. So there has been some state planning going on. The Oklahoma Water Resources Board, if you hit the next slide, finalized their comprehensive water plan just in 2012. And the goals were, of course, to characterize the demand, identify supplies, and perform some technical studies and engage stakeholders. So next. And so where can we get water? Well, here's a map of the streams in Oklahoma. You can see some blue lines and some areas that are a little darker, and those are the reservoirs. And so that's the existing surface water resources. So we can take water from streams if there's a sustainable or a reliable enough source. We can also take water from reservoirs. Of course, streams can dry up, and reservoirs can dry up too. This map shows some aquifers. This is the groundwater across the state. It's not evenly distributed. A lot of it is just along streams or the major rivers, and there's a few usable aquifers, notably the Ogallala Aquifer that's in the western Panhandle, and the Panhandle, Texas actually extends all the way north to Wyoming. But the next slide. In looking at water supply sources in the year 2060, and the study is quite interesting, is that they said, well, where will the water come from? And so the darker areas you see are projected from groundwater, and the lighter colored areas are from surface water. And so where in the state can we expect to get our major water supply in the year 2060? Next. The basic problem, I guess I want to get across, though, is that this is water in streams, and this is an annual cycle. So this is our spring season, this is the summer season, so we're above normal in the spring, we're below normal in the summer. In the summer, next, this is for irrigation and agriculture, we have the most demand, and also urban demand increases during the summer too. And so there's a basic problem of distribution in space and time. That is, when the rainfall occurs in the spring, we need to save it for summertime, or if we have a wet year, we need to save it for the dry years. Next. So in anticipation of that, the Water Board actually looked at a number of locations for future reservoirs. These are category 4 and 3, or 3 and 4. That just means that these have few limitations. These could be built. And so you can see there's about 68 viable reservoirs, all the little diamond symbols there across the state. These could be built. And I'm proposing that that's one solution to solving the drought problem. It's a longer-term solution because it takes a long time to put these reservoirs into place, to do the planning and design studies. Next. So Lake Thunderbird, it's located up here near Oklahoma City. You can see this blue area here. Norman is right next to it. This is our water supply. So more than likely, this is where this water came from, was Lake Thunderbird. Earlier last year sometime, the water ran off from the streets of Norman into the lake. So that gives you some idea of the cycle that we're dealing with locally. And then there's a pipeline from southeast Oklahoma. There's 2 reservoirs here. This is our wet area in terms of runoff. And it's shipped via pipeline up to Lake Stanley Draper, and then Oklahoma City can distribute it to their water system. And we can also buy water when we run out in the summertime here in Norman. And so we could, through Lake Thunderbird, the district that operates the lake can actually have the Oklahoma City open a tap to the pipeline, so to speak, and buy some water temporarily. Next. So it provides, this lake provides water for Norman primarily. It was completed in 1964. And I want to get to the next slide here. This is the rainfall variability courtesy of the Oklahoma Climate Survey, going back to the 1900s. And so these are decadal kinds of behaviors. So next. And we're right here at about 26 inches for the year in 2012. And so the question is how variable is the climate? Well, you can also see that historically it's been quite variable too. Each one of these dots represents the annual rainfall. So climate variability is nothing new. Now climate change may be new, and one thing I think the climate change debate has done is raise the public's awareness. There is a climate, and it is variable. And so trying to predict the future is a very difficult task, but we can always look backwards. So this is going back to 1926. The Bureau of Reclamation built Lake Thunderbird, and they do these studies. And what you see here is lake level. And so the blue area is lake level. The red is spilled water due to flood releases or just excess water. So we have a little bit of water that we spill from time to time. Next. You can see in this period, this is when the dam was actually built. So you might ask, well, how do I know the lake level before it was built? Well, that's the beauty of a computer model. We can set up a system and we can model that. And you can see periods where the lake actually decreased. This is actually the drought of record in 1957. And the hope is in planting these reservoirs is if the lake was full at the beginning of the drought of record, the most severe one, would you be able to have enough water to make it through that drought? And you can see in 1957 it's quite severe. And other periods too. And so back in the 20s and 30s, and this is the Dust Bowl area here. And so current time is right here. So we're right here. We have kind of a precipitous drop. It's not the worst that we've had. We've had probably the lowest level back here in the 70s. So there are some periods that equal that. And what you see, this decrease here, you should be concerned about that. So what does that represent? That represents if we took the drought of 2011 and 2012 and projected that forward, we just had the same weather. That is the climate change, and it's exactly like it's been the last 2 years. You see the lake is basically going dry. There's a spring season and a little bit of runoff to tease you to think that you're going to come out of the drought. But the net effect is that over time it'll dry out. Now there are 2 significant events in 2011 and 2012, so if you go to the next slide, next. And if we take those 2 significant events out and still have the climate of 2011 and 2012, 2011 and 2012, you see it decreases and we'll be dry in about 2 years or 3 years in 2016. So basically our reservoir will be just a mud puddle. So that would be the effect of having the continuation of the drought of the last 2 years in central Oklahoma on that water supply. Next. So what can we do? Well, we can increase supply. We can build more water supply reservoirs and pipelines to try to solve the time and space distribution. We can drill more wells and maybe develop more marginal aquifers, marginal meaning maybe lesser water quality, but with some treatment that could be used. And then water reuse. This is recycling of wastewater, and it's done throughout the country, particularly in the arid areas. We can try to decrease demand. It won't solve your problems, but it will help water conservation, reduce losses where you can, promote xeriscaping or low-impact development. And lastly, I'd say improve our knowledge and management through better science and technology and engineering for water, high-resolution analysis of water processes, advanced hydrologic modeling, and detailed rainfall and evaporation measurement. And so all of that together helps us devise better management strategies because we know where and when the runoff will or has happened, and then we can develop appropriate management strategies to handle that. I think I'll leave it right there.